Hi, I'm Jack,
And I'm Paul.
and this is a math adventure with Jack and
Now
Paul.
times 2 equals next.
These are the linear growth rules. For the recursive rule, it would start at 1, and we would do now, meaning the prior, plus 3 equals next. For the explicit rule, it would be y equals 3x plus 1. This is the table for the recursive and explicit rule I described in the previous slide. If we start at 1, which means 0 is 1, and add 3, it will give you 4. Continue on 7, 10, 13, 16, and 19. This is the graph for the recursive and explicit rule and table of values I displayed in the previous slides. You can see that it is a consistently straight going up.
This is the linear decay equations. The recursive rule is start equals 210, now minus 10 equals next. Explicit rule is y equals negative 10x plus 210. This is the linear decay table of values for the previous rules on the other slide. As you could see, by every one, it decreases by 10. So it goes from 210 to 200 to 19, and goes on like that. As you can see, the graph for the linear decay is a straight line because it goes by the same number each time.
These are the exponential growth equations. The recursive rule starts at 1, it's now times 3 equals next. Explicit rule is y equals 1, 3 to the x power. This is the table of values for the exponential growth equations. You can see that the previous number times 3 equals the next number. So 1 times 3 equals 3. 3 times 9 equals 9. 3 times 3 equals 9, sorry. 9 times 3 equals 27. 27 times 3 equals 81. 81 times 3 equals 243. And 243 times 3 equals 729. This is the graph for the exponential equations. You can see that it starts at a pretty steady, it starts going up, but it's not easy to see on this because the numbers are so low. But then it rapidly increases towards the end.
As you can see, this is the exponential decay equations. The recursive rule is now times 0.75 is equal to next. The start is 210. The explicit rule is y equal to 210 times 0.75x. This is the exponential decay table of values. As you can see, it starts from 0 and goes to 6. The 0 starting is 210, and then it goes from 157.5, and then goes on timesing by 0.75. As you can see, this is the graph from the table of values listed in the previous slide. As you can see, it's like a slope coming down. So the number of M&Ms is decreasing by the number of cycles.
So back to the original problem. There are two types of wallabies. One wallaby begins running and picks up 3 miles every hour. The other type of wallaby begins running and it runs 3 times faster than the last hour ran. The first wallaby is linear growth, which means that it will continue going up by either addition or subtraction. In this case, addition. So in 12 hours, how many miles would the first wallaby gone? For the section 1, it is exponential growth, which means that you can find the next value using multiplication or division. In this case, multiplication. For the work of these equations, you can see that you would do y equals 3x plus 1, and then you would substitute x for 12, or substitute 12 for x plus 1, and that'll give you 37, because 3 times 12 is 36 plus 1 equals 37. And then for the exponential, you would do y equals 1 times 3 to the 12th power. 3 to the 12th power is 531,441, and you would multiply that by 1, and you'd get 531,000 to the 531,441.
As you can see, this is the problem for the linear decay and exponential decay. So the first question is, what minute does Billy finish eating all his M&Ms? The second question is, when does Billy's kidneys filter out half of the 210 M&Ms sugar. How I got the answer was I put the number 0 because you're trying to find the when Billy finishes eating his M&Ms. So you would do minus 210 on both sides, and then you would get negative 210 equals to negative 10x, and then you do negative 10 on both sides, divided by negative 10 on both sides, and then x equals 21 minutes. Exponential decay. My question was, when does Billy's kidneys filter a half of the 200 M&Ms sugar? And I got between the second and third cycle, because in the second cycle it's 118.13, and in the third cycle it's 88.59, and then between that is 105. So in between the second and third cycle is when Billy's kidneys filter a half of the M&M's sugar.